I'm Eric Hassman. I'm CEO of Nature Inspired Industries. I'm here to tell you a little bit about some pretty cool products we've developed. Thanks for sticking with us this long. We've got a problem with materials. A lot of the materials that we use right now are, they produce a lot of pollution. And we think we've solved a little tiny piece of that in the composites market. What we've done is we've developed a new set of composites based on a biomimetic design based on a shrimp. It's called a mantis shrimp. First, why biomimicry? A lot of you guys have been to a couple of different things here looking at biomimetic things. Nature is a great teacher. It's been about 3.5 billion years, 1 million different generations to develop the optimal structures, and we need to learn from that. This is a mantis shrimp. It is unique. It's developed a set of clubs at the front of its body. It has the fastest strike in nature. It's faster than a speeding bullet underwater, creates cavitation. There's a group that we've licensed this technology from at UC Riverside, which analyzed this club, which essentially has to survive tens of thousands of bullet strikes without breaking. They found that this thing has a very unique structure, and they mimicked that structure. It's a helicoid structure. They mimicked that structure in a composite form, and they tested it and found that it is stronger than the composite that Boeing is currently using at its new generation plane. Pretty interesting stuff. So we think that this has a wide set of applications in a wide variety of different industries. Automotive, you've got wind, you've got some of the sports equipment. We're very proud of this stuff. Just in automotive, for example, we have the ability, we think, from our calculations, to take down the weight of a vehicle between 30 and 50%, which is pretty significant. If you guys think about the CAFE standards that are in place, 2025, I think it's 54.5 miles per gallon, which is an incredible goal. This material, we think, can get us 2/3 the way there, just this material. Big market in composites. It's $28 billion. The question is where to start. We're going to start a little bit in the automotive section. We're going to start a little bit in the sports equipment. Our financials are, it's a licensing model, so it's sort of OpEx light, and we're going to rely on a lot of the channel partners that already have established sales. We think it'll have a very significant environmental and social return by reducing the amount of carbon fiber and other materials that it replaces. Great management team, 100 years of experience, and we're in discussions with all kinds of partners. And that's what we're looking for. Thank you. Questions?
Yeah. I think it's a great idea to learn from nature. And given your set of materials, I have actually two questions. So what's the composite element in it? And the other one is, where in the supply chain of industries that use this kind of composites you will apply your license?
That's a very good question. So we've decided to pursue licensing just for it costs a lot of money to set up a materials producing company. But I think we've decided to start at watercraft, which is kind of an interesting place to start. The time to market is a lot closer. Automotive is more like 3 to 5 years in terms of cycle, so we're going to be around for a while for that. Does that answer your question?
Partly, but I just wonder, if you talk about the license model, what will you exactly license? The use of your material, or the production process related to your new material, because it goes together, of course?
We're going to license our IP, and so the IP is around the optimal angle of the fibers within the composite structure, and that's a little technical, but the helicoid structure has a particular set of angles that are optimal, and we're looking to license that IP.
So, what type of competitors are out there? There must be a lot, from my hunch. And second, we all know what happened with the Boeing 787 and when it came to manufacturing. What type of testing has happened thus far in manufacturing processes?
The testing is still early stages. So what we've done is there's an ASTM standard that Boeing uses as drop tests, et cetera, for example, for impact resistance. And we have replicated that process and found it's at least 50% stronger. So that's kind of our beginning testing. We've also partnered with the Army Research Lab in Aberdeen to conduct a lot of anti-ballistics testing on the material. So we're in early stages, but early stages, the data is good.
I actually worked on the 787 program, and you're right, there were a lot of problems with how it was implemented. But the primary savings, sort of environmental benefit of the 787 program was the lightness of the airplane, which made it more efficient. Is that the main environmental benefit that you're seeing that this product is demonstrating?
It is the primary benefit. However, current composites, most of the material is not recyclable. But we have had some initial discussions with folks to have recyclable polymers depending on application, which is why I'm interested in talking to the gentleman here later on.
Awesome.
Just a quick clarifying question. You said you're patenting the angle by which the materials come together. Can you clarify, do you actually have a patent to date? And if you don't, how defensible do you think that technology is from that standpoint?
Patent's in place.
It's in place, okay.
Patent's in place.
Sounds good.
Thank you, guys.
Thank you.